our next section, we determine what types of triangles we have based on their side lengths. We have three specific types of triangles we have to choose from. We are in each case given three vertices. So we're going to use the coordinates of the vertices of a triangle to classify the triangle as scalene, isosceles, or equilateral. Scalene triangles have no sides that are equal to each other. All the lengths of all three sides are different. Isosceles triangles have two or more side lengths that are equal, and equilateral triangles have all three side lengths that are exactly the same. What I do to figure this out is I want to compare the side lengths of all three sides. And if I don't have a picture, I'm going to use our distance formula to figure this out. Even if I did have a picture, not all the time are pictures drawn to scale. What I think I'm going to do is I'm going to find the distance of AB, then I'm going to find the distance of BC, then I'm going to find the distance of AC and compare them. One other piece of advice, we're also going to take a look to see if we can determine if any of these triangles are also right triangles. So let's begin with question 6. From A to B, I'm going to use the distance formula. Unlike writing it out the last couple of times, I'm going to try to do some of the work in my head. The change in the x from 2 to 4 is 2 units, so a leg would be 2 units. The change in the y, the vertical leg, would be from 1 to 6, 5 units, and 5 squared would be the square of that leg. Add these together and square root them. 4 plus 25 is the square root of 29. The length of AB would be 29, square root of 29 units. Again, I'm finding the distance between the x's, the distance between their y's, squaring them and square rooting their sum. Let's move on to B and C. From 4 to -1, their difference is 5 units. We'll put a 5 squared plus the vertical leg. From 6 to 3 is a difference of 3 units. 3 squared. 25 plus 9 makes 34. The length of BC is 34 units. Square root of 34 units. Lastly, from A to C. From +2 to -1 is a distance of 3 units. So the horizontal leg is 3 units long. The vertical leg looks like it's 2 units long. And let's square these, add them together, and square root it. 9 and 4 makes 13. Okay. These three side lengths are all unique. We have a scalene triangle. Is this a right triangle? Now this was side length BC. It was the longest side. If it were a right triangle, this would be and represent the hypotenuse. If I take this side length, square it, that side length, square it, add them together, it should equal this side length squared if this is a right triangle. Square root of 13 squared is 13, square root of 29 squared is 29, 13 added to 29 makes 42. And square root of 34 squared is not 42. This is not a right triangle, it is scalene only. Moving on to our next exercise. Again, we're going to find the distance of AB, BC, and AC. Excuse me. From A to B is a difference of 4 units. So the horizontal leg would be 4 units long. The vertical leg from 7 to 4 is a difference of 3 units. 4 squared is 16 plus 3 squared is 9. 9 and 16 make 25. The square root of 25, okay, this simplifies to be 5 units. From B to C. 7 units would be the horizontal length of the leg, the horizontal leg length. 4 to 3 is a difference of 1. 7 squared is 49, and 1 squared makes 1. 1 more than 49 makes 50. The square root of 50 needs to be simplified. The largest perfect square that goes in a 50 is 25. It goes in twice. So we have 5 root 2 is the distance between point B and point C. Finish this with AC. 3 is the length of the horizontal leg. 4 is the length of the vertical leg. 9 and 16 make 25. The square root of 25 makes 5 units. Noticing that two lengths, but not all three, are the same length, I know this is an isosceles triangle. Something else is striking about this. If the length 5 root 2 is the longest length, when I square that, I get 50. When I square these and add them together, I also get 50. This is also a right triangle. How do I know this again? When we square the three side lengths, if the two smaller ones squared added together makes the largest one squared, then we have a right triangle because of the Pythagorean theorem. Here's our last exercise. This one looks a little more challenging. Let's see what we can do. From AB, the horizontal length would be 0.5. I'm going to write 1/2 plus 0 to root 3 over 2 is a difference of root 3 over 2. So the change in the y-coordinate is root 3 over 2. Let's square both of these fractions and add them together. 1/2 times 1/2 is 1/4. Square root of 3 squared is 3, and 2 squared is 4. 1/4 plus 3/4 makes 4/4, or 1. The square root of 1 is 1. Side length AB is 1 unit. BC, the distance horizontally is 1/2. The distance vertically is again square root of 3 over 2. And since we found the last time we did 1/4 plus 3/4 gave us 1, the square root of 1 is also 1 unit. So now, I know that this triangle is isosceles. I can also test if it's equilateral. And you wouldn't test if something is equilateral unless you knew that the first two times you knew that it was isosceles. So equilateral triangles are also isosceles, but it doesn't work the other way around. Let's find the distance between A and C. So I do notice the y-coordinates are the same. They have the same y-coordinate in common, which means they're found on the same horizontal line. The difference of the x-coordinate is 1 unit. This is an equilateral triangle. So technically, I'm going to put down that it is isosceles, but it's more specific to say that it is equilateral. Is it a right triangle? In order for this to be a right triangle, it has to have a hypotenuse, a longest side. It's sort of contradictory to say that it has a longest side and all three of the sides are equal. So because all three lengths are equivalent, I know it cannot be a right triangle. This is the end of our video. Let's move on to our next one.